So our fourth section in Unit F is about scale diagrams, and scale diagrams are pretty useful if you've ever planned a renovation or figured out how to fit a potentially new couch into your space. You might have done scale diagrams. So there is some graph paper and some scale diagrams for you to draw on the next page. We're going to walk through a few examples here of how to do calculations, and they're very much like those similar triangles that we were doing before. So there's a proportionality statement, or there's a scale that is given with scale drawings. And so oftentimes, you might see these on architectural drawings or design plans, or even on maps. Sometimes the scales come with units, and sometimes they're just whole number ratios. And so in this one, we have a drawing of a fridge over here, and we can see on the drawing it has a height of 2.5 centimeters. If I wanted to figure out the actual height of the fridge, I could set up a proportionality statement with the drawing measurement over the actual measurement. So the drawing measurement is this 2.5 over we don't know, whatever this one is. This is our question mark. That's what we're trying to solve. And then this is my whole number ratio. This is my scale. So 1 in the drawing would be 40 in real life. And so they're all sorted across like this so that the drawing measurements are always on the top and the real life stuff is actually on the bottom. So solving this one, I would take the 2.5 times the 40 divided by the 1. And I'll set that up one more time. So top times the bottom, and write it on one side, equaling the bottom times the top. So it'd be 1 times L. Getting L by itself, I divide both sides by 1. And this is what I actually just do on my calculator in one fell swoop. So you get the actual height as being 100 centimeters. The drawing measurements were in centimeters, and so the answer is going to come out in centimeters. This is a case where a scale doesn't have units on it. The next example on the page does the same thing for the width. And so you take the drawing, 2 centimeters, over whatever the width is in real life, would be proportional to this scale that you were given about this drawing. And so in that way, you can determine in real life what would the width of the fridge be. You can always include the units as you do the calculations. The next example is about a floor plan drawing. And so this floor plan drawing has a scale where 1 centimeter equals 5 meters. And so this scale has units attached to it. We want to figure out the actual width of the building if the drawing is 15 centimeters. So I'd have 15 centimeters as the drawing is over, I don't know, whatever we want to call it, I'm going to call it X, is equal to 1 centimeter over 5 meters. It's not necessary to put those units in. If they do help you put the right thing in the right place, then by all means, that's a really practical bit for them. But in my mind, oftentimes I don't put those ones in. It's really up to you. In my calculator, I'd have 15 times 5 divided by the 1. And so in my calculator, I'd figure out that it's 75 meters for an actual width of the building. The last example on the page gives me a scale of 1 to 40 for this kitchen. We have a drawing down here. I'm going to switch away from orange. I don't know, sometimes I get in orange. I think I've morphed the drawing a little bit as I was editing notes. So that one should measure 9 centimeters and the other should measure 7 centimeters in this layout of a kitchen. If we want to figure out the length in real life, and the width in real life, we're going to do that with this scale that we're given. So let's start with the length in real life. The length would be 9 centimeters over we don't know should equal 1 over 40. You can put the units with these. These are in centimeters, and we don't have units attached to these. So that tells me my answer is going to come out in centimeters. So I'd have 9 times 40 divided by 1. So that would give me 360 centimeters, or that might be more practical to say it's 3.6 meters. If I do the same thing for the width, I would have the drawing measurement over the actual real world would equal the 1 over 40. This is going to scale it up to be the measurement in real life. So 7 times 40 divided by the 1 here gives me 280 centimeters. All right, the next page is drawings that you can draw for yourself. So I'm going to just switch to my answer key that's already done, save you having to listen to me kind of bumble my way through it. It's really interesting to do this in this analog version of things, but I do think that computer technology has made this work a whole lot better. And things like SketchUp or other drafting and design programs have this functionality kind of built into them. So we've moved away from the pencil and graph paper in a lot of ways, but I really do think that this is a good skill to have, especially if you want to try and figure out your own living space or that kind of thing. You ever want to like build a tree house for kids or any of that kind of stuff? This idea of scale drawings is really useful to make calculations from for real world stuff.